The next project is basically automatic sun tracking system. So basically a sun tracking system is a system in which, like a sunflower, as your sun moves from one direction to other direction, it basically follows the sun such that the panel is always perpendicular to the sun, and that can happen in, generally there is something called as Uttarayan and Dakshinayana. The sun moves like this also, just not by this to this, but it also goes from 6 months here and 6 months there. So basically to cover that, we build another secondary axis, so which will rotate the panel in other direction. Now a sun tracking system with a fixed panel. So if you have a fixed panel, you will get a curve like this. It will peak at some point and it will go down. But if you have a rotating panel, your curve will go like this. So in the morning time, obviously you won't have much effect, but in the afternoon time, yes, definitely. So that's why, and this peak is generally whatever direction. So right now they are using this peak because most of them are using it as a hot water source. But electricity generation wise, there could be different points. So basically the tracking system can be a closed loop. Depending upon LDRs, it can sense where the maximum energy is coming from and it can adjust the panel. In our case, we are using something called as astronomical equation, where depending upon your latitude and longitude, the sun's position is always fixed, and that is given through astronomical equation. So you need not search for the sun. And then there is something called as maximum power point tracking. So once you know that sun is, this is my panel facing the sun, and once you know that sun is perpendicular, now you just rotate this panel plus minus 10 degrees and see if there is any cloud or something like that. Then the maximum power point would have shifted somehow to another angle, which is within the vicinity, so that we just move our panel by plus minus 10 degrees and we make sure that it always gives me, so this is a V curve and I curve if you see, and there will be a point, this is a power plot, and there will be a point where the VI product will maximum, and that called is MPPT, maximum power point tracking. So voltage peaks somewhere differently, current peaks somewhere differently, but voltage into current peak might be some at different time. So this is again with respect to time or theta. So what we find out is MPPT point for different thetas, and we will compare them, and wherever is the maximum MPPT, we will select that. So this is basically 3D diagram, and so it will have V, I, it's called characteristic curve, and different thetas. We'll get the MPPT point accordingly. Next is, so once we said that we are going to build a hardware based on microcontroller, a LCD panel, a keypad, servo motors for azimuth and servo motor for elevation, and there will be a panel. This is how the hardware will look like, and from the panel voltage feedback we will calculate the MPPT. So there is some V2I converter and etc. ADC unit, measure the voltage, some resistive load, and then the battery will be charged by panel itself. So battery to run the, this becomes my block diagram with sun tracking, basically sun panel, solar panel, what you call it, this servo, secondary servo. Servo has its original angular full tank inherently fed.